Okay, guys, can you hear me, everyone? Okay, can you see me? How are you all? Doing well? Doing good? So, what all things we learned last class? I think last class we covered a lot of things, right? Okay. Okay, box Cox hypothesis and all done, right? So let's first of all quickly finish today's topics, and then probably I will also be discussing some very important things that I really want to say, because anyhow our sessions are also getting over. More Today is the last class with respect to statistics, but further on we will be doing many things in practicals also. Okay, and today I'll also cover some of the more practicals, and further classes Sudhanshu will be taking, and he will also be explaining and including all these things. Just give me a second, and before I start, uh, 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 uh. but I hope you all are doing well, everybody. Guys, is my voice clear? Okay. For the people who are facing voice trouble, please check your net connection. Okay, I will know if my net connection is bad. I'll definitely let you know. Okay, perfect. Let me open my whiteboard. Okay, let's start. I'll just share my screen, then probably we'll start. Okay, so first of all, let me stop my video, and let me tell you what all things we are going to discuss quickly today. One is regarding why variance we use divide by n minus 1. This we really need to understand. The second thing that is remaining is chi-square. Okay, and the third topic that is remaining is ANOVA. Okay, and then I'll call someone to basically, I think anybody will be able to explain this Poisson distribution. Okay, and please try to, anybody who can, they will just raise, I'll tell them to raise their hand and explain about Poisson distribution. Okay, this, and we'll also include practicals part, where we'll discuss how to implement all this Z test, T test with the help of Python programming language, and we'll cover all these things. And yeah, we are pretty much good. We have covered most of the topics, and then when you will be learning about EDA from Python, most of the things will again come, right? So all these things we'll try to cover up. Okay. Yeah, Shweta Kumari over here, F test will come. Okay, and don't worry. Okay, F test usually comes here in ANOVA. Okay, don't worry. We'll talk about it. Okay, so Khushbu Singh says, "Sir, I have a doubt why we calculate degree of freedom and we don't. We used, right, guys? We did not use degree of freedom. Degree of freedom we used, right? In where did we use? We used in T test, right? T test. Why do we use degree of freedom? Because over there population standard deviation was not given, right? So we actually used this degree of freedom. Please revise your lectures. Before coming the class, please revise. Okay, your lectures. Otherwise, if you ask the silly questions after explaining all the things, then it will be waste of time for you also, waste of time for me also. Okay. So first of all, let's quickly go and discuss about why sample variance is divided by n minus 1. Okay, this is the first question. Everybody stop messaging in the chat and focus over here. Okay. Now remember guys, let's go ahead and try to first of all understand what is mean. Suppose I'll first of all discuss with respect to population, and then I will discuss with respect to sample, right? Now mean, basically over here, if I say I is equal to 1 to n summation of x of I divided by capital N. I hope everybody agrees with this formula. Yes, everyone? Anybody who does not agree? I hope everybody agrees with this, right? Simple. Now variance, which I will also be writing as sigma square. What is variance? Summation of I is equal to 1 to n x of I minus minus mean whole square divided by capital N. I hope everybody agrees with this. This capital N. Okay. This was with respect to population. Now let's go ahead and try to discuss with respect to sample. In sample, we used to write x bar. Okay. In x bar, summation of I is equal to 1 to n x of I divided by n. And variance, which I will write it as V, will be given as summation of I is equal to small n x of I minus x bar whole square divided by n minus 1. This is the real formula with respect to the sample variance. Okay. Now understand, why did we not divide by n? Okay. See, we can also write something like this. We can also write this definition as I is equal to 1 to x minus x bar whole square divided by n. Okay. We can also write like this. Okay. And we can also write like this. Okay. This kind of estimation of estimation of variance is basically a biased estimation. I'll explain you what exactly is biased estimation, and this is usually called as unbiased estimation. Okay. Deepak Singh, please check your internet. Okay, internet connection. Okay. Again, I'm telling you guys, please check your internet connection. I have a 5G internet. If guys, everybody is able to see my screen and what I'm writing, right? Yes. See, all the people are saying. See, guys, if you have internet problem, that is not my problem. No. Okay. Again, some people is saying my audio is glitching. Come on, everybody check your internet connection. My internet connection is perfectly fine. Audio is perfectly fine. Everybody is saying, everybody is able to hear. If you're not able to hear, please try to rejoin again. Okay. And don't try to disturb the class. Okay. Okay, fine. Now, why this is called as biased estimation and unbiased estimation? Okay. And let's see this. Suppose I have this sum of the points. Let's consider that I have some of the sample points I'm going to consider like this out from a population. Now tell me, if I want, suppose this is my sample. If I really want to find out the mean, probably I can consider my mean will fall somewhere here. Let's consider that it falls somewhere here. Okay. Or let me do one thing. Just let me rub this. Okay. And let me make one more line. Suppose I have some of the points. Let's consider that I have some of the points in my population, which looks something like this. Okay. Now tell me, if I try to find out the mean, then what may happen? My mean may fall somewhere here for this population mean. I hope everybody agrees. Yes or no? Yes, everybody agrees. Let's consider that our mean will fall somewhere here at this point. Now what may happen is that, suppose if I take a sample of values, suppose if I could take a sample of values, the sample of values may be taken in different way. I may pick up this element, I may pick up this element, I may pick up this element, I may pick up this element. Suppose this elements is there in my first sample. Then obviously if I try to calculate this sample mean, it will fall somewhere here. Sometime it may fall somewhere here, right? Now what if, suppose my sample that is selected is very nearby, like this, only these 3 samples have got selected. Then what will happen, guys? Tell me. Our mean will be here itself, right? Everybody agree with me? Our mean will be somewhere here. Yes. Now just imagine, what is this biased estimation? Okay, biased estimation. Biased estimation basically says that if my sample is selected just nearby over here, it is which is very much far away from your population mean, right? It is very much far away from your population mean. So what they do is that instead of dividing by n, they try to divide by n minus 1. Now tell me, if I try to divide this by n minus 1, whether this value will be greater or whether this value will be greater. Which of them will be greater? This n minus 1 will be greater, right? Yes, it will be greater, obviously, because this n value over here will be smaller, right? Over here it will be larger. Okay, so it says that even though they try to select a different sample value, or a sample wherein the entire sample mean is far away from this population mean, then also what they do is that they try to make this as an unbiased estimation, because if they try to select this kind of sample, it becomes a biased selection, right? It becomes a biased selection. Yes, because you are trying to select the similar type of things, right? I hope everybody's agreeing, guys. Yes or no? Just let me know. I hope everybody's agreeing with this, right? So just understand what happens. Suppose if I just select this 3 elements as my sample. Okay, if I select these 3 elements, will this selection be biased or not? Because all are there only, right? In that same location only, nearby location only, right? So whenever we have this kind of selection, we cannot, if we divide by n, what will happen is that our mean will be falling somewhere here only. We have to make sure that we basically make it as an unbiased selection. Now, for making it as an unbiased selection or estimation, what we do is that for calculating the mean or the variance, what we do is we divide by n minus 1. Is it clear, guys? Understand two things, two terminologies that I have actually told. Over here, biased estimation and unbiased estimation. Unbiased estimation over here. Now you may be thinking, Krish, why n minus 1? Why not n minus 2? Why not n minus 3? Why not n minus 4? Why n minus 5? Why n minus infinity? Why, Krish? I'll kill you. Why you said n minus 1? Okay. So for this, understand, scientists performed various experiment. Definitely they performed experiment with n minus 1, n minus 2, n minus 3, n minus 4 and all. Okay. So it was found out that if you try to divide by n, understand two terminologies which I told about. What is an estimate? I discussed about estimate, right? Yes or no? Guys, I discussed about estimate in my previous session. Estimate, right? And I discussed about what is parameter. Let's consider. I'll try to discuss again this. Suppose if I say this x bar is my sample mean, can I say this is an estimate of the parameter population mean? Yes, 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 yes or no, guys? I hope everybody agrees this. If I say x bar is an estimate of the parameter, which is a population mean. Now, whenever what I was doing is that from this, the scientists found out that whenever they are picking some elements of samples and when they are dividing by n, it used to be a scenario wherein this x bar was very, very less than mean. Again, understand, guys, what I'm repeating. I'm repeating it, okay, over here. So scientists performed experiments. In this experiments, what they did is that from this entire population, see, there will be a population over here because we have our population mean. From this entire population, they used to pick up various samples and they used to find out the sample mean. Okay, and sample variance, sorry. They used to find out the sample variance. Now, when they were finding out the sample variance, when they divided by n, this n, okay, divided by this sample n, sample size. This is my n is nothing but your sample size. N is nothing but your sample size. So when they were dividing by small n, this x bar that was actually getting computed was very, very less than mu. Okay. And when they started dividing by n minus 1, then what happened? It was becoming approximately equal to the population mean. And when they were dividing by n minus 2, this was becoming greater than the population mean. And similarly, when it was becoming by n minus 3, it was again becoming greater than population mean. How do I say this? So for this, I will show you one portal. Okay. So everybody can try this portal. This is from Khan Academy. from this particular portal. I'll just send you all these things. Okay. Okay. Now see this, guys. Over here, please see this diagram. Everybody got this portal link? Can I get a quick yes? See, I've given you the ping. Just give me yes. I hope I've given you the ping, right? So everybody open this. Now let's see what happens. Understand, this first one is basically dividing the variance by n. The second one is basically dividing the variance by n minus 1. And third one is basically dividing the variance by n minus 3. Sorry, n minus 2. Now see what will happen. Now, if I click on this, see, these are three options. If I click on add 50 samples and I was calculating the variance, so some points will get created like this. See, understand this line that you see everywhere, that is the true variance of the population. But here I'm adding samples. See, I'm adding samples, okay? Like this. Now let's add it continuously. Now see, what is happening over here, guys? What is happening over here? Can you see over here, guys? See, the variance over here is getting reduced, right? Over here, see, it is not meeting the true line. Over here, there is a huge gap. After taking many samples, over here, what do you see? Initially, there was some disturbance, but finally it is meeting the true variance. And when you took n minus 2, what is happening over here? Remember, this green color line is basically divide your n minus 2. Just understand this, and this is the gap it is trying to show you. I hope now you are understanding what I said, guys. If you divide by n, if you divide by n minus 1, if you divide by n minus 2, so what will be the problem over here? What will be the problem over here? With the help of n minus 1, it is saying that after some time, you will be approximately equal to the population variance. With the help of n, if you try to divide by n, what will happen? It will always be less than population variance. So can I say this as my biased side? So that is the reason to remove that biasness, I'm actually dividing it by n minus 1. Okay. Similarly, if you do n minus 2, n minus 3, n minus 4, this graph will go and jump up like this. Does this make sense, everybody? Yes or no? Let's start it once again. Okay. If you are getting confused, let's start this. See, I'm just trying to hold two simultaneously. See what is happening. After some point of time, as you take more and more samples, which is meeting the true variance? Which is meeting the true variance? It is n minus 1. Okay. So this is the most important thing that you really need to understand. Why do we divide by n minus 1? Why do we divide the variance by n minus 1? Okay. So in interview, will you be able to explain? Yes. Interview, very important question this is. Why sample variance is like, do we divide by n minus 1? So very good. Very good. I hope everybody is able to understand. Okay. Easily explained, I hope. Again, thanks to Khan Academy, where you will be able to get free education and all. It's an amazing thing. And again, if probably we also get some kind of funding in the later stage from great people like Elon Musk and all, we'll also do the same thing. Why we are not dividing mean by n minus 1? See, Mohit, that only I told you, right? You can use the same concept for mean also. For mean also you can use it. Okay. But understand, variance talks about the distribution. Variance talks about the spread, So mean is just a measure of some central tendency. But when you measure a distribution, you really need to apply this thing. Okay. For mean, mostly they don't use this thing. But yes, if you want, you can definitely follow this also. Okay. Clear? Shall I continue, guys? I hope the first topic is done, right? Let's not waste time. Quickly, we'll try to finish so that I have some time to talk to you, so that I'll try to tell you what all things you really need to focus on statistics. What in the interview point of view? Okay. What in the interview point of view? Black color is the sample mean and green is the true mean. Population. black color is the sample mean. Okay, let's answer that later. Okay, I hope that's simple to understand. No, how can this black color be the mean? It is just showing you some gap, confidence interval, like kind of thing. You know, your this value may be ranging from this to this, like that. Okay. See over here, it says the solid line is the true variance. The black dots in each graph show the variance calculated using the population mean instead of the sample mean. Just read this, you'll be able to understand. Okay. Okay, guys. So let's continue the discussion, and the next topic that we are going to discuss is something called as chi-square. Okay. Excited for chi-square now? Everybody who's waiting from last class only, sir, we did not hear about chi-square. Why, sir? Why? Why, Krish? I am saying, guys, we'll learn by order. Don't worry. Everything will learn by order. Okay. Now, what you know about chi-square? Tell me. Anything that you know about chi-square. So first of all, always remember, guys, I know I've given it as homework, but no one will do the homework, you know. And if I give just you for the homework, and if you don't do this also, no, later on when Sudhanshu will come for the class, you'll say that Krish did not teach us this. Krish did not teach us this. So suppose I have given Poisson distribution as homework. I'll not teach this. Let's see. If you want, I can create this YouTube video. Okay. I'll not teach this today. Now you see tomorrow what will happen. Sudhanshu will, Krish did not teach us this. Krish is very bad. This, you know. Whereas in school and colleges where people give you the entire syllabus as homework, you'll be happy with this. So this kind of situation is there. Can't help. Okay. Okay. So let's define chi-square test. Okay. So chi-square, it is a non-parametric test. Non-parametric test that is performed on categorical data. Okay. So this is a very important definition. Always remember, guys, whenever people or whenever in interview they ask you regarding any test, first of all, you really need to know why this test is basically used. And this is the most important thing. Whenever, like in short, I know, see, interviewer will also not go in deep inside to asking you that what is the equation and all. They'll just say that why do you use chi-square test? Okay. So here I've actually written. Please don't type in the chat over here. Focus on the session, guys. It is a non-parametric test that is performed on the categorical data. Okay. Now let's, very simple, right? Whenever you have categorical data, whether you have 2 to 3 categorical data, in order to perform a test to find out the relationship between categorical data, you do some kind of test. Okay. We'll see some examples and then you'll try to understand it. Okay. Now let's go ahead. Let's write an example, guys. Write the example today. So the question is very simple. In the 2000 census, in the 2000 US census, the age of individual in a small town were found to be the following. So this is the table that you have. Less than 18. See, these are your features. These are your category features. 18 to 35, greater than 35. Okay. So these are your features. And this had like 20%, 30%, and 50%. Clear, guys? See the question, everybody. In the 2000 US census, the age of individual in a small town were found to be the following. So less than 18 was having, the total population was 20%, 18 to 35, it was 30%. Greater than 35, it was 50%. Okay. Then after this, in 2010, ages of, this is my sample, n is equal to 500 individuals were sampled, and below are the results. Less than 18%, less than 18, 18 to 35, and greater than 35. So the values were like 121 were present in less than 18 to 35 were 288, and greater than 35 was 91. Now using alpha is equal to 0.05, can you conclude the distribution of ages has been changed in 10 years? Just by seeing it, can you come to a conclusion, guys, whether the age has been changed or not? How do you say it has got changed? Okay, okay. Many people are writing. So let's see, how do we solve this particular problem by using chi-square test? Okay. Now, what is the first step in all that kind of tests? Tell me. What is the first thing I have to do in this kind of test? So let's start. So first thing, step 1, null hypothesis. So what will be a null hypothesis? Can I write the data meets the something, anything you can write. I'll just write like this. The data meets the age distribution. Right? That basically means no change has happened in the past 10 years, like that. Or data meets the age distribution. So this is the question, guys. Let's read the question once again. In the 2000 US census, the age of an individual in a small town was found to be the following. Less than 18%, 18 years was 20%, 18 to 35 was 30%, okay? Greater than 35 was 50%, okay? In 2010, ages of n is equal to 500 individuals were sampled. Below are the results. Less than 18 was 121, 18 to 35 was 288, and greater than 35 was 91. So using alpha is equal to 0.05, you can conclude that the distribution, can you conclude that the distribution of ages has been changed in 10 years or not? Okay. So my null hypothesis will be the data meets the age distribution. H1 is nothing but, okay, distribution of age has changed. Clear, everybody, with this? Yes or no? Everybody agree to this? Null hypothesis, alternate hypothesis? Okay, perfect. Now the second step. Your alpha is given as 0.05. Okay, so what is the confidence interval? Do you agree with this? Perfect. The third step is calculate degree of freedom. So calculate degree of freedom. Now, degree of freedom is very much simple. What it will be? How many number of categories I have? Guys, you should see with respect to categories. How many categories I have? 3, right? So it will be 3 minus 1, 2, right? Now, how do I find out with respect to this degree freedom and this alpha value? So for this, everybody open your chi-square table. Ashutosh Pandey, there is no noise in my headphones. Guys, is there any noise in my headphones, in my voice? Everybody, see, nobody is saying there is a problem. It is crystal clear they are saying. What should I say you? Okay. I'll not entertain this kind of questions now. From that time, he's asking the same question. Okay, chi-square table. So go to the chi-square table. Go to the chi-square table. What is the degree of freedom, guys? See, the degree of freedom is nothing but 2 along with 0.05 significance value. So the value will be 5.99. Is everybody getting this? Yeah. 5.99. Okay. Remember, in here degree of freedom is given and here alpha value is given, not CI value. Okay. Alpha value is given usually in this particular table. How to create this table? I think this table has already been calculated and given is available over here. But anyhow, I'll tell you the formula of this chi-square also. Okay. So can I conclude? What can we conclude by seeing this, guys? So what do I conclude? So the fourth thing is that we will state our decision rule. Our decision rule will be saying that if my value, the chi-square value, see, chi-square is basically given like this in this notation. Chi-square is greater than 5.99, then what we'll do? We'll reject the null hypothesis. Everybody agree? Yes? Okay, perfect. Now let's go ahead and try to find out how do we calculate this chi-square test statistics. The fifth step, calculate chi-square test statistics. The formula for chi-square test statistics is very much simple, guys. We use this is equal to summation of frequency of observed minus frequency of expected divided by frequency of expected, and this will be whole square. Now, what is this frequency of observed, frequency of expected, frequency of expected? I will try to tell you guys. Okay. So let's compute this. First of all, let's see. Everybody remembers this table, right? Everybody remembers this table. Yeah. So here I will write again less than 18, 18 to 35 and greater than 35. What is the value? 121, 288, 91. Yes. Let's consider that from the sample, this is the observed value. So what is this? This is my F0, observed. What will be my expected value? F1. How do we calculate our expected value? Okay. Total sample, how much we have collected? We have collected 500, guys. Yes or no? Now this expected is basically calculated based on these values that are given of the population. So what we do is that we multiply this 500 by this 20%. That basically means that out of this 500, 20% will be less than 18, right? So what is 500 multiplied by 20%? Can I write this as 100? Yeah, perfect. What is See, because 20 by 100 is nothing but 0.2, right? So 0.2 multiplied by 500 will be 100. What is 500 multiplied by 30%? 30% of 500? It is somewhere around 150. 150. And then this will be around 250. I hope everybody agrees with this. Yeah. And just by seeing this, you can obviously say, yes, there is a difference. But again, we have 95% confidence interval, right? So what we are going to do is that we are going to apply this particular test statistics formula now. So my formula will be like this: summation of F0 Fe divided by Fe. Now, if I try and calculate what it is, 121 minus 100 divided by 100. For this less than 18, I can write like this only, right? Guys, I hope everybody understood how do we calculate this. It's very simple. From the sample, what we did, whatever was the population percentage, we just multiplied it. Like 20% of 500 is how much? 100, right? Then 30% of 500 is how much? And don't tell me now, Krish, I don't know how to compute that. See, it will be like this: 100, right? So if I multiply this will be 150. So 150 is over here, right? Now let's go and calculate. Now 121 minus 100 divided by 100 plus, what is the second one? Frequency of observed is 288. 288 minus 150 whole square divided by 100 plus 91 minus 250 whole square divided by 250. And this will be x square. Calculated, how much will be? Oh, sorry, this will be 150. Yeah. Tell me, guys, calculate. Calculate. Are you getting 232.94? Kanak Gupta wants compute. I hope you will be getting 232.94. Okay, 494. 222.94. I hope everybody is getting this. Now tell me quickly your conclusion. Here x square is greater than 5.99, right? So you reject the null hypothesis. What does this basically mean if you're rejecting the null hypothesis? So in the past 10 years, the age has got changed, right? So here you can conclude that the distribution of age has got changed. Clear? Good problem statement, easy problem statement. Samruddhi Deshmukh says, why we reject at greater than 5.99? Because here we had seen, right, in our decision rule, it has shown that it should not be greater than 5.99, no? Based on the table. Yes, Som Mohanty, we can definitely say that there is a drastic change. So if they ask you whether the age has decreased or increased based on the population, right? You can definitely say that it has got increased. Atul Rai says, by looking at the data only, we could say distribution is changed. Yes, distribution is changed. But here the main thing is that significance value, the alpha value, right? Here, by using 95% confidence interval also, okay, by having 95 confidence interval. Now there may be some problem statements, right? If they say 95% confidence interval, that time you can basically consider of rejecting the null hypothesis and accepting the null hypothesis like that. Sir, can you please take an example, one more example? Can you please take an example where we accept the null hypothesis? It's very simple. Instead of taking alpha is equal to 0.05, take alpha is equal to 0.75 and try to see. Different situation will be there. Sherin, understand, no, over here what we are doing, why we are using this. Now, Sherin question is that why did we do 3 minus 1? There we took sample minus 1. Here, why did we took 3 minus 1? This is also, this is mainly for categorical features, no? Understand, for categorical data. Yeah, so categorical data is over here. What is this? Categories are here, right? So here we are focusing on number of categories. We have 3 categories. Okay, let's take values also. You have 3 values if you want to consider in that particular way. But the main thing is that we have to focus on this. Okay. Okay, let's Indranil says, why we use alpha as 0.5, not point. Alpha is not 0.5, alpha is 0.05. Indranil, did you not attend our previous sessions? Sorry, Naveen, did you not attend our previous session? Naveen? Attended. There we discussed about this alpha value, no? Significance value. Okay, there are 2 Naveens. Huh? I'm talking about Naveen Vinayak. Naveen Vinayak. Because I don't understand. Sorry, Naveen Aswal. Sorry, not Vinayak. Naveen Aswal. Extremely sorry. So understand, why do we use alpha value? Alpha value is basically given by a domain expert. Significance value it is called as. How much confidence interval you have to take. Please revise the previous concept, guys. Trust me, now you are in the last class of the things and still you are confused in significance value. That basically means you have not given enough amount of things, for preparing. Chi-square ka formula is little confusing. If we add do 10 multiplied to the population and mixture, the chi-square value also change. No. Understand what is over here, what we are trying to find out. Observed and expected. Expected basically says that based on this popular distribution, our expected value should be that only. But once we took the sample, the observed value is something like this. Okay. Okay, let's do one more example, guys, quickly. Yes, everybody ready for the second example? Yeah. Okay, let's take the second example over here. This is called as chi-square test for independence. Chi-square can also be used to evaluate the relationship between 2 categorical variables. Between 2 or more category variables also we can write. Shravan Kumar says, why if chi-square value less than? I will not answer this now. if you are asking question related to why when it is less than something, why do we evaluate this? So I'm sorry, you have to revise from the previous lecture. Okay, so let's take up this question, guys. People have forgot everything from the past. Some guy is saying, what? That is not my problem. No, you should revise things. 7 days are given to you and you're not revising. What should I do? Tell me. Every time I'll revise that same thing. From the first class, this is 10. Okay, 500 elementary school boys and girls. See, go and write this question, guys. Are asked which are their favorite color. which are their favorite color. Blue, green, or pink. So these are the three possible colors we have. Results are shown below. Okay, so the results look something like this: blue, green, and pink. And this is with respect to boys and girls. Okay, let's consider. Let's see your common sense. Okay, blue will be selected by many boys or girls. Okay, many people are saying boys. So, okay, you are absolutely right. So this is 100, this is 20. What about green? Green, girls, equal. Okay, so in green can be selected by both boys and girls, but here boys have selected more. But I think, what about pink? Pink, obviously, many people will say girls. Okay, fine, perfect. So 20, 180. Okay. What is the total of all these things? Total 150, 150 and 250, 250, 270. This is 50, 230. Okay. And then I basically have total as 120, 180, 200. This is the total, guys, right? Let me remove this. So if I try to find out the sum, it is nothing but 500. So this is my n value, right? Okay. Now this is my entire table. Okay. Now my question is, using alpha is equal to 0.05, would you conclude there is a relationship between gender and color? Again, common sense, right, guys? Yes or no? Yes, it's visible, right? Okay, let's do it statistically. Okay, so null hypothesis, tell me. Gender and favorite color are not related, or I can write are related. Are related. H1, gender and favorite color are not related. Clear? Khushbu Singh, usually we select the positive one over here. Not is basically selected over here. Okay. Gender and favorite color are related, and here are not related. Okay. Or here I can also make it alternative. Okay. So let's see over here. This also we can do it like this. Gender and color are not related. Okay. And this also reverse I can do. But make sure that you, when you're performing the experiment, that way also you can actually select it. Okay. Clear everybody till here? Okay. Now tell me what will be the next step. Degree of freedom, right? So my step 2 is alpha is equal to 0.05. We have this. Step 3 is calculate degree of freedom. Now here the degree of freedom will be changed. Why? The formula will be changed. Why do you think? Because you have two categories, right? See guys, you have two categories. One is this, one is this. So in this particular case, we need to apply in this particular way. So the degree of freedom in this case will be rows minus 1 multiplied by columns minus 1. In all the possible options, rows is basically for what? Rows is basically for what? Rows is basically saying boys and girls, right? So out there, we need to see how many degree of freedom is there. So this will be 2 minus 1 multiplied by 3 minus 1. So obviously it is going to be 2. Okay. So you know what is step 4? State decision rule. Now in degree of freedom as 2 and alpha is equal to 0.45, what is the decision rule? X square should be greater than, if it is greater than, x square is equal to 5.99, right? If it is greater than 5.99, Naveen Ajay Kumar, again I told you, right? This formula changed because now you have genders and you have other column of colors, right? So here I have taken as rows and columns. Two different categories are there. So if x0 is greater, x square is greater than 5.99, we reject h0, right? Yes, Indranil, this values come from the table, no? Chi-square table. Again, you want me to open the chi-square table? See over here, 0.052. Degree of freedom is 2, no? 2. I have calculated it over here. Suraj, see rows minus 1 and column minus 1. Guys, you all are not focusing on the session. Come on, focus on the session, right? I'm telling something and everybody. Okay. Perfect. Now, finally, the step 5. Step 5 will be calculate chi-square test. Chi-square test formula is same. Summation of f observation, f event square divided by f expectation. Okay. Shrikant, take alpha value as 0.10 specifically for you. Okay, if you are not interested in taking 0.05. I told you, no, domain expert decides here. Now, guys, over here, the problem is that f of expectation, how do we calculate it? Because we don't have the data like how we had in the previous stage, right? We have this specific thing. So how do we calculate it? Now, understand this f of expectation will be calculated by this formula, f of columns, f of rows divided by small n. What is f of columns? Let's see this, okay? Let's consider boys and girls, boys and blues, okay? Let's take this combination first. So first combination, I want to take boy with blue. And I have to apply this formula, okay? So what is f of column? 100. Do you agree, everyone? Yes or no? Yes, yes. So this will be 100 multiplied by f of rows. What is f of rows? If I add this up, how much it will be? Let's consider this pink is 50 to make it as a full number. So it will become 300. Let's consider this as 50 so that it become a full number, guys. Just for easy sake, I'm doing it. Okay, 300. So this 100 multiplied by f of rows is nothing but 300 divided by what is n? What is n? 500, right? N, guys, small n, right? 500. So what is the calculation over here? Is this 72? Sorry. Yeah. Is this 60, right? Sorry. 60? Yes. Ones are 6 are. Okay. Why you're saying n is equal to 530? Oh, yeah. Let's do one thing, guys. I wanted to make this as a full number. What was the previous number I gave? What was the previous number I gave? 20, right? Okay, let's consider 20 for sakes. Number 6. So this will be 270. Let's make this as 270 right now. So 100 multiplied by 270 divided by 500. Just do it, guys. I just wanted to make it a whole number, so because of that I did it. 5 ones are 5 twos are 27 twos are 54. Okay. So what is f of e of boys with blue? It is nothing but 54. Similarly, calculate for boys and green. Boys with green, guys. Just calculate boys with green. Calculate boys with green. So it will be nothing but 150 multiplied by 270 divided by 500. 81. Okay. Let's go and calculate for boys and pink. Boys and pink. Boys and pink will be very simple. 20 multiplied by 270 divided by 500. 10.8. Perfect. Okay, perfect. Now, similarly, you have to do it for girls with blue, girls with green, and girls with pink. Quickly tell me. Okay. Okay, what is girls with blue first of all? 9.2. Okay. Girls with green. Girls with green, how much? 13.8. Girls with pink, 82.8. Everybody got it? अब फॉर्मूला में अप्लाई कर दो ना. f of 0 minus f of e whole square divided by f of e. Now let's take first one, boys and blue. Okay, boys and blue, what is the observed value? What is the observed value for boys and blue? 100, right? So can I write like this now? 100 minus 54 divided by 54 whole square. Then I'll do plus. What is boys with green observed value? Boys in green with observed value is 150, right? I hope you're understanding, right, guys? So this will be 150. 150 minus, what is this? 81 whole square divided by 81. Then plus boys with pink. Boys with pink, how much value you have? Observed value? 20, right? So 20 minus 10.8 whole square divided by 10.8. Then plus girls with blue, how much is the observed value, guys? Someone tell me quickly. Someone tell me. What is the observed value? Girls comma blue. 20, right? So 20 minus 9.2 divided by 9.2 whole square plus what is girls with green? How much is the observed value? 30 minus 13.8 whole square divided by 13.8 and plus what is the final value? 180 minus 82.8 divided by 82.8 whole square. भाई calculate कर लो यार. I hope you'll be able to calculate this. Simple. Calculate it, guys, and tell me one value quickly. $251.6. Perfect. Absolutely fine. Now x square 251.6 is greater than 5.99. So what does this basically say? Conclusion. Reject S0, accept H1. फर्क पड़ता है. Okay, perfect. Okay, good, guys. See here, what was the main focus? Two different things you have, right? Two different altogether. What you have over here? Two different categories, and you are able to compare two different categories, right? At the end of the day, you'll just be using all these things for doing your EDA part, you know. No. See, genders and colors are not related, but this is proving that they are related or not related. They are proving that it is related, right? If decision rule and calculated value are equal, how do we conclude? Then obviously we have to accept the null hypothesis. Yes, there is a relationship between gender and color. You can also say that there is no relationship, there is a relationship. You can say that. Rohit Shinde, the question will be given over here, you know. Would you conclude the relationship is between gender and color? Abhishek, F value, where did I explain F value over here? This is frequency of column, frequency of rows. Surya Narayan, already I told you, no. See this question. Would you conclude there is a relationship between gender and color? I've taken the null and the alternate hypothesis with respect to that only. There is a relation, there is not a relation, like that. if we take the alternate one for null hypothesis, see, first of all, try to consider an experiment. Okay. See, I have this specific data. I don't know why people are getting confused. See, when you have this specific data and this question is asked whether there is a relationship between gender and color. Okay. Now, always understand you will be performing some experiment. If that experiment is giving something greater than that particular value, you have to reject something. If it is coming less than that particular value, you have to accept something, right? So by default, what did we do over here? Genders and colors are not related. We have taken first of all by default, and here we have taken the second one is they are related. How do we say this both are related? How do we say this both are related? Tell me. How do we say this both are related? Tell me, guys, how do we say this both are related? See, how do we say, just think with respect to a specific experiment. The experiment will be done by taking this specific data, and by taking this specific data, if it comes something be within the 95% confidence interval, then I will say that this is related, right? See, the data is given to you over here. Some specific data is given to you for performing some specific experiment, right? Always understand this thing, guys. You need to consider, see, the data, whatever is given, based on that, you really need to make an assumption of H0 and H1. I am going to perform that particular experiment. If that value is greater than that particular experiment, this will get rejected. Now, when this entire data will get rejected, what is this data all about? What is this data all about? To find out whether there is a relationship between gender and color or not. Right? So that is the reason why I've taken the null hypothesis as gender and color are not related. Yes, Deepak Singh, you're absolutely right. Okay. Guys, clear? Yes? Yes, Praveen. Just to clarify, is there any criteria to select H0? Like H0 is selected such a way that it should support the problem statement or should be opposite of the problem statement? Yes, see. Now, what you are saying, whether we should support or we should not support. See, H0 will make sure that they will try to support this statement, whatever is given in the problem statement. They'll try to support this. If it is proven wrong, we need to reject the null hypothesis. That's it. H0 should be decided in such a way that it supports the problem statement. Okay. I was trying to say that thing only from that much time. Nikhil, are you clear now? Anuranava Nag says, so in case H0 and H1 is interchange, then the alpha will change and our calculation will be towards the particular alpha value. Yes. But here we choose in reverse. Ashish, understand. Again, I'm telling you, supporting and not supporting basically means what? Over here, you're saying that gender and color are not related, right? For H0. Oops, sorry. I think then this will be R related, guys. Okay. Sorry, my mistake. Gender and color are not related. Okay. Clear now? Gender and color are related. Gender and color are not related. But guys, just make sense. No. Just see this. Just see this, guys. Now, if I try to make these changes over here after performing the experiment, we are getting something else which proves and says that the gender and colors are related, right? Over here. See this experiment, guys, over here. Okay. Just see this. The experiment basically says that the gender and color are related to each other. You know, the boys, they are selecting more blue, more green. Girls, they're selecting more pink, right? So some kind of relations are there, right? So before one only looked correct. This should have come are not related, are related. Because see, by this particular way, what it will happen is that your problem statement, just see your problem statement. No, just see your problem statement. Which do you which what do you think from this particular data proves? It is more towards related, right? It's more towards related. Yes. So suppose it's not directly, we also have to see the problem statement. Okay, we also have to see the problem statement. Okay, we have to see the problem statement over here based on this particular data. Now see, over here, by just seeing this specific data also, we can come to a conclusion whether this color and gender is being related or not. Just try to observe this data, just try to see. Okay, after performing the experiment, anyhow, the value that we are getting, right, the value that we are getting over here, we're getting something greater than this. Okay, but don't worry about this particular topic, guys. What I'll do is that I'll still explore, because still there are some confusion with respect to alternate and null hypothesis. Okay, so this is the main confusion, right? Everyone is having how to select your alternate and null hypothesis, right? Don't worry. So I will try to make a video on this also. Okay, specific to a problem statement. Okay, so don't worry. Okay, don't worry. I will try to make a video for that particular case. Okay, let me explore a little bit more, because I also felt some amount of confusion over here when we are discussing about this. Okay, because if we have this kind of data, and if they say, who do you conclude there is a relationship between gender and color? So we could add saying that is a confusion, there is a relationship, there is not a relationship. And by default, what I see over here, there is a relationship. That is the reason we are getting so high value. Okay, so don't worry, I will just give me a couple of days, I'll explore it, and I'll upload a video with respect to selecting the null and the alternate hypothesis, because this problem statement I took from a book. Okay, and that book had actually given are not related. Okay, I'll make a video which says that how do you select an alternate and null hypothesis from a problem statement. Okay, is it clear? So just give me a couple of days, no need to worry, I'll try to fix it. Okay, but other than that, the problem calculation, everything is understood, right? Yeah, I'll make that topic, how do we select the null and the alternate hypothesis from a business problem. Okay, but the thing is that, see, over here in this case, okay, just focus everybody. Okay, just focus over here. Now see, what happens is that when we have this kind of thing, right, when we have this kind of statements, just by seeing, you can definitely say that there is a relationship between the gender and the color. Okay, gender and the color. And in this particular case, I'll tell you why that book has selected not. Okay, why that book has actually selected not, because just by seeing this, there is an exact relationship. Okay, and if this experiment right now, whatever we performed over here, the experiment failed. Now when the experiment failed, okay, experiment failed, this basically shows that there should not be a relationship, but they took it in an inverse way. Okay, I have to really check it out why specifically they have taken in this inverse way, because if I reverse this, right, if I reverse this alternate and null hypothesis, okay, if I reverse this, then there will be a problem again, because gender and color over here are definitely related. right? So अगर फाइनल रिजल्ट गलत आता है तो H0 and H1 चेंज होता है. Yes. So let's see. Don't worry. I will try to have a look. Okay. Okay, guys. Don't worry. I will try to take it up. Okay. Yes. Everybody clear? I will try to do it. Don't worry. Just give me a time. But everybody, I think, other than that, you understood the entire simple things with respect to this, right? Whatever you really need to understand with respect to the calculation, right? Calculation is very much easy. All the calculation, I think, chi-square, everything. Here it was pretty much simple, right? Chi-square is pretty much simple. Whether it will follow that distribution or not. That's it. Okay. So just give me some time, okay? Because I don't know why that book has taken not, because I just verified from the book also it is taken not. Okay. Okay, perfect. Okay. So till here, happy everybody, apart from when to select H0 and H1. Don't worry, see, in real world problem also, when you're doing machine learning and all, no, that issue will not come, because most of the questions will be related to something else. Okay. So chi-square is completed. This is completed. Okay. Now let's do some practical. You want to do some practical, everyone? Okay. So I'll give you one GitHub link. Just give me a second, guys. I'm just taking out my GitHub link, and then you'll be able to see this. Okay. So I'm giving you this GitHub link. Everybody download it. Everybody download from this GitHub. See, this is the GitHub link I've given in the chat. All with formulas has been given over here. I would suggest just do it, guys. Just do this. Just follow from bottom to last, and just try to see whether you're able to understand or not. I think you'll be able to understand, because I think correlation is repeated over here, because I have explained you about correlation earlier also. Everybody check the chat, please. Crosstab is equal to confusion matrix. I'll talk about it. Wait. So overall, how was the experience with respect to statistics, guys? Something you learned better or not? At the end of the day, you should understand. At the end of the day, what I feel, whenever I want to teach anyone, at the end of the day, you should clear your interview. Okay. I don't want anything other than that. I may teach you some things with confusion, but don't worry. At the end of the day, you should basically be able to. Okay, one guy says too much confusion. That basically means you will require a lot of revision. Okay. I can't help if there is so much of confusion after doing. So this is our 6th class, Do you know, guys, this is your 6th class. I don't want to be a novel literate in statistics and all, but I just want you to teach in such a way that everybody should be able to clear the interview. That's it. And that much amount I will teach you very easily. Don't worry. Okay. Okay, let's start. Everybody ready? If by seeing the data I can say there is a relationship in the distribution, then why should we perform test to conclude that? Can it be an interview question? See, Atul Rai, you are just thinking about one or two records. In machine learning problem statement, you'll be having 10,000, 20,000 records. You'll be having 40, 50 features. Vikas Kumar, see, time is everything, Vikas Kumar. Okay. And it is very much important that you revise at least 1 hour. Don't tell me that you don't have 1 hour also. Okay. So you don't tell me that you don't have 1 hour, Vikas. Okay. So at least one day you have to give 1 hour. We cannot give you one entire week off because we also need to complete the portions, right? Okay, guys. So everybody downloaded this file? Yeah. Okay. Now, guys, I know, see, some of the libraries you have not known, like Seaborn. Okay. That will come. That will probably start from tomorrow's session only. Okay. But understand the Seaborn is a visualization library. It will actually help you to create some graphs. It also has some of the default data sets, okay, which you can actually load. Now let's see. Here we are again. Here I'm not teaching what is this stats library, pandas and all. Okay. If NumPy is also not done, don't worry. We'll just try to see how this formula is getting applied. And here I told you, what did I say, guys, when we are doing coding? What value we will compare? I told you something about p value, right? You remember? I told you about p value. If p is less than 0.505, what will happen? If you remember, right? All these things I told you. While calculation time, we see the decision rule, but while coding time, we see the p value. Okay. Now see this. First of all, we are importing the stats library because all the tests like Z test, T test, chi-square test, ANOVA test is all present inside the stats library. Okay. Now here we are going to import this library called as the tips dataset, and the tips dataset looks something like this. Okay, 16.99. These are my tips dataset. Now, why do we use chi-square test? Why do we use chi-square test? Come on, tell me. Interview question. Kartiban says categorical. What categorical? Why do we use chi-test? How do you answer this? To find out the relationship between category features? Can I say that? Yes. Please try to tell the entire answer, guys. Then only it will be very, very helpful. Now, in this particular case, let's consider our category features as sex and smoker. Okay. Now, here we are writing a code which says pd.crosstab. This is present inside pandas. What we are doing is that we are basically making in this particular format. Like how I define the format in this, right? Sorry. Just a second. So if you remember, guys, over here, what kind of format we defined? We defined in this format only, right? This format is what? This is crosstab format. Okay, matrix format, crosstab we basically say. Boys blue, boys green, boys pink, like that. Okay. So similarly, we are doing this thing also. You can add any number of features also. Okay. Like if you want to add one more feature, you can add it over here. So here I'm defining this. Okay. So this says male. How many of them are smoker? 60. In male, how many of them are less smokers are there in male also? 97. Female, 33 are smoker and 54 are not smoker. Everybody clear with this? Yes. A simple matrix we have created, 2x2 matrix this is. Okay. Okay. Now see this. First we have to calculate the observed values. What is our observed values? Can I say these all our values are my observed values? Yeah, these all values are my observed values, so I have got my observed values. Perfect. Now I just have to use chi-square dot contingency, and I just need to give my data set table, which is my observed values. So automatically it will give us this. Okay, did I not execute this one? Okay. See guys, once I apply this, this val will give us many results like this. It will give this many values. Okay. What is val of 3? What is val of 3? Expected values. We are getting this. See, 3 basically means 0, 1, 2, and 3. Okay. So what is this? This is my expected values. Okay. This is the accepted values that is calculated. This is my observed values. This is my expected values. Clear? Yes? Yes or no? How do we calculate accepted values? फॉर्मूला लगा दो यार एक्सपेक्टेड वैल्यूज का फॉर्मूला है ना ये राइट very much simple. Then you have this number of rows, number of columns, this all the formula, you apply it and you apply the chi-square test directly. Okay, so this is your initialized values with all the things. Degree of freedom is calculated. Then this is your alpha value. Okay, don't worry about all these things guys, focus on this thing right now. Okay, I'll tell you when I really need to tell you, because these all are not that important for your data science work. Okay, which are important, I'm going to tell you that. Okay, because there are many parameters that it gives, you have to check the documentation page. Okay, clear everybody with respect to this? Yes. Now this we apply the chi-square formula. Once we apply this chi-square, we are just applying this sum, right? This values we are giving over here and we are getting this, right? If I get this is my chi-square statistics. Chi-square statistics. After I get my chi-square statistics, this is my chi-square statistics. See this, the entire computation I'm getting as minus 0.0019. And then we need to find out the critical value. Critical value is based on your decision rule. This is my critical value. Now, is this value greater than 3.84? No, right? Sorry, I think this chi-square statistics is later being used. This entire value is later being used to compute the p-value in this particular formula, which is called as chi2.cdf. And then finally, you'll get a p-value over here, which says the p-value is 0.96. Yes, the alpha value selected is 0.05. See over here, alpha value is getting selected as 0.05. Okay. Now see guys, what is the p-value that is computed from this calculation? It is nothing but 0.964. Okay. And this significance level is 0.05. Now over here, see the condition. If chi-squared statistics is greater than or equal to critical value, reject S0. There is no relationship. Sorry. There is a relationship between two category variables. Or there is a relationship between, there is no relationship between two category features. So if I execute this, I'm getting the same output. See, with the help of chi-squared statistics also we'll get the output. With the help of p-value also we'll get the output. Done? Very simple, right? It is saying retain H0, retain. See guys, this chi-squared statistics is this formula only, no? What is this? This formula. This formula, no, chi-square statistics. This formula, see, we computed chi-square statistics, right? To compute the, and this critical value is your decision rule. Decision rule. To compute your p-value, we apply a different formula. To compute the p-value. See, I told you, no, with the help of chi-square statistics also you can do, with the help of p-value also you can do. So I am showing you both way. So here I've got my chi-square statistics value. This is my value that we have got from this formula. Which formula? This formula, right? This formula. And then we are calculating the p-value by different formula. This is like chi-square dot 2 dot CDF. CDF basically means cumulative density function. We just need to give this statistics value over here and degree of freedom, and it will automatically calculate your p-value. And then we are just writing a condition. If chi-square statistic is greater than or equal to critical value, we reject or retain. If it is less than or equal to alpha, we reject or retain. That's it. And both of them are giving the same output. No, that basically means that you can perform this experiment by using chi-square statistics also, by using p-value also. P-value basically, guys, p-value, this p-value. Clear? Now just try and see about t-test and whatever we have learned, whether it is correct or not, guys. Just see. Critical value is a method defined in Seaborn class, not in Seaborn. This chi-square 2, chi2 is basically coming from where? It is coming from this SciPy stats, no? SciPy stats like. Now just try to see t-test, z-test and tell me, guys, whether you are able to understand or not. Y in critical value, 1 minus taken value, y. I think here we need to give the confidence interval, Uday. Okay. If you go and see this function, it will tell you percent point function inverse of CDF at Q of a given RV. You can just see all these parameters. I think over here, they'll give you the confidence interval. Everybody see t-test. And these all examples, I think we have done this theoretically also. Correlation is very much simple. I think I don't have to test. ANOVA test will actually help you to compare 2 to 3 groups. We'll also discuss about it. Wait. Quickly tell me. Over here, what we are doing in t-test, we have taken ages and we took a sample of ages, like some sample size. And then we are probably checking with the help of t-test based on a p-value. And we are basically saying if it is less than 0.05, we are rejecting or accepting the null hypothesis, right? See, in t-test, what we are doing, you have a sample of ages. And from that, we are picking up some samples. We are performing the experiment and we are basically saying that if the p-value is less than this, we have to reject or accept the null hypothesis. Some more examples, like we are trying to compare from school ages with class ages here also. And here also you can see some p-values, right? This is 2 samples with t-test. This is the formula that is basically applied if you have 2 different samples. And this also we can actually perform just by using this simple stats t-test underscore end. All the functions are basically present over here, guys. Deep, what you're saying, when 2 sample t-test will be covered. This is the formula, no, Deep. Again, why you want me to again create a problem statement and write this formula for you? So I've shown you practically also, no? This is your Poisson distribution, guys. This will actually help you to create Poisson distribution data. Okay. We saw, right, yesterday one more technique, Poisson distribution, not, sorry, in the last class we saw, right, how to create a logarithmic data, right? How to create a logarithmic distribution data, exponential distribution data. Similarly, if you want to create a Poisson distribution data, you can use this. Okay. Ritik Ras says, what is p-value? Guys, tell me what is p-value now. Have I not discussed about p-value? How did you decide the state decision rule? I did not decide, guys. This automatically, we have taken the alpha value as 0.05, no? So automatically what it has done is that it has actually found out the state decision rule. Automatically this is done. The library itself has done. See over here. This critical value is basically that only. Here they have given the confidence interval 1 minus alpha. In 2 sample t-test, you are getting an error. Then execute from here, no? Guys, execute from the starting only. Okay. Come on now. See, we have understood all these things. Now you just need to perform an experiment and try to check it out. If you are saying that you are getting an error over here, just try to execute the top one, guys. I'm able to execute over here. See, every time you execute it over here, what is it? Class A height. Class A underscore height, where it is? Not there. So class A height. Okay, sorry, I should have taken class A ages instead of height. Just change it to ages. Okay. See, we have defined this, ages. Just try to define it over here. We are rejecting the null hypothesis. We are accepting the null hypothesis. Everything will be. P-value computed from the statistic test. See, specifically, if I talk about over here, chi-square statistics is your value that you are getting after performing the test statistics. Critical value is basically based on a decision rule. And this p-value is basically computed by using this chi2.cdf in chi-square. And in all the other thing, after we perform this statistics test over here internally, it gives us two things. One is t-test value, one is p-value. P-value, basically you are using over here to determine these things. Okay. Clear, everybody? Good enough? Correlation is very much simple, right? See this? Correlation, what does correlation basically say? Suppose I say petal length and sepal length is 87% correlated, right? 87% correlated. That basically means as the petal length is increasing, sepal length will also increase. Everybody agree with me? What is this minus value? Tell me. Sepal width and petal width. What does this basically say? Negative correlation or what? No, you should not say no correlation. Inverse correlation, negative correlation, you have to basically say. That basically means as the sepal width increases, petal width decreases. Or as the petal width increases, sepal width decreases. Right? Inverse. Okay, let's discuss about ANOVA test quickly. Before that, you want 5 minutes break? Let's finish it quickly so that we will be able to talk and complete, you know. And I also, today we will talk a little bit, okay, so that okay, let's take 5 minutes break, then after that we'll finish and we'll talk, okay. Okay, so 5 minutes break, everybody come back till then, okay. Okay, guys. Everybody, back. Okay, I have also created a detailed video regarding this particular particular topic, so you can check it out from there with the same example. Okay, so this is the video that I already created with respect to all the tests. You can actually go and check it out. Okay, so yeah, and one more thing. Just a second. And guys, I'm telling you quickly, start learning stats properly. Okay, stats are important. They will ask you questions, not this kind of questions where they're telling you to tell about the equations and all, but instead all the other things that we have discussed, right? That is very much important. Okay. Final one example we'll see with respect to F test or ANOVA test. Okay. So just let's read this. Okay. The t-test works when dealing with two groups. Okay. But sometimes we want to compare more than two groups at the same time. For example, if you want to test whether a petal width age differs based on some category variables like species, we have to compare the mean of each level or group the variable. I hope you are understanding this, guys, or not. Right now, we have mostly done with respect to two groups, right? What if a numerical and a category feature needs to be compared? Like what if a numerical feature along with a category variables like species needs to be compared? So there are various kind of examples. And one of the example is one-way F test. It tells whether two or groups are similar or not based on their mean similarity and F score. Example, there are three different category of iris flower and the petal width and needs to check whether all three groups are similar or not. Okay. So this is the example that we are doing. Over here, we have loaded iris flower dataset. So this flower dataset has four features. One is sepal length, sepal width, petal length, and petal width and species. Okay. Now, suppose if I take this petal width and species, suppose I'm taking these two features. You can see over here, with the help of this example, we are taking these two features. Okay. And if I go and do these groups, how many unique value I have in species? This is nothing but Setosa, versicolor, and virginica. So what after this we can actually do? See, if you go and see over here, okay, over here, this is what I want to get. See, with respect to Setosa, these are my petal length. See, sorry, petal width. See, these all are my petal width with respect to Setosa flower. Okay, Setosa is a type of flower, iris flower. And here what I'm doing is that I'm grouping this based on this particular flowers. Okay. So over here, versicolor is there. I'm grouping it with respect to this particular flower. And virginica is there. I'm grouping it with respect to this kind of flowers. I hope everybody is understanding. So here what you have done, this is nothing but dictionary key value comprehension, we can say. Okay. Based on group, we are just trying to read the petal width. Okay. So for groups in groups, okay, so these groups are there for groups in groups. I'm just comparing that this from this particular data frame. Okay, I'm taking the petal width wherever the species is matching to this group, and based on that I'm taking out this particular information. Yes, we can also perform group by operation in data frames. After that, I am saying that I'll use the stats.f underscore one way. This is used for F test. I pass out my Setosa data, versicolor data, and virginica data. Okay, and then now we are trying to compare these three groups, whether these three groups are equal or not. Now tell me, just by seeing this data, do you think these three groups are equal? Just see this data, guys. Why do you say that these three groups are not equal? Because obviously, if you go and compute the mean, don't you think all the mean value will be different? Yes? Yes or no? Mean is very, very much different. Okay. Mean is very, very much different. Probably over here, if I go with respect to virginica, this flower size will be more. So if I go and see this p value, what is this p value now? See this p value is, sorry, I did not execute this d data. And I will compute this. And now if I go and see my p value, what is this p value? 0.000000 something like that, right? So this is obviously less than 0.05. So we are going to reject the null hypothesis and accept the, sorry, accept. Just a second. Did I just clear? Yes, everybody. I hope you are following me, right? So we are trying to compare the groups within all these things. Sorry, this will be reject and this will be accept. I'll tell you why I did reject and accept. Just a second. Okay. Now see this, guys. Over here, I'll talk about the formula also. Don't worry. Over here, when the p-value is less than 0.05, we are rejecting the null hypothesis. This basically says that all this particular mean is different. Yes or no? I hope you are agreeing with me. Yes or no, guys? Just see this. All this mean will be different, so we have to reject the null hypothesis. By default, null hypothesis will be considering that all the means are equal, right? Now, if you want to go and see what is the formula for F test, I can write the formula for you guys. Okay. Let me write down the formula for F test, because again, there are so many things that we really need to consider. Again, these all formulas are not that important. Okay. In F test, we basically use different formula. Let me just search for it in the Google if otherwise. F one way ANOVA formula. It will have multiple formulas, guys. This is the final formula, MSC divided by MST. Okay. Let me do one thing. Let me just make a problem statement. Everybody wants to solve a problem statement on ANOVA test? Yes or no? Okay, let's do it. I know, because I know you'll not be satisfied, because sometimes I teach in such a way that after that, if I just reduce little bit of the quality, then automatically everybody will scold me. Okay. Everybody, please write down the problem statement quickly. So the problem statement is very simple. Researchers wants to test a medication. This medication is nothing but anti-anxiety. They split participants in 3 conditions. 0 mg, 5 mg, and 100 mg. I'll show you the data set how it is. Okay. Then anxiety level is checked on scale 1 to 10. Are there any differences between the 3 condition? And here also we have to use alpha is equal to 0.05. Let me put the data sets, guys. Just a second. I will put the data set for you all. But till then, please everybody write down the question, and at least something did you understand from the question or not? Something did you understand from the question or not? Anything that probably you can understand. So this is my data set, guys. See this. Okay, now see everybody. Researchers want to test an anti-anxiety medicine. They split the participants in three conditions. Then after giving, the anxiety level is checked on the scale of 1 to 10. Are there any differences between the three conditions? So by giving 0 mg, this was the anxiety level. By giving 5 mgs, and remember, this is for the person 1, I guess. This can be for the person 1, person 2, person 3, person 4, person 5, person 6, person 7. Okay. And alpha is 0.05. Okay. Now I hope everybody understood the question. Yes or no? Now tell me what will be your alternate and null hypothesis. I think for this kind of scenario, it is very simple. Can I say something like this? My null hypothesis can be mean of 0 mb equal to mean of 50 mg equal to mean of 100 mg. Just to say that there is no difference. Yes. H1 is mean of 0 mg is not equal to mean of 50 mg is not equal to mean of 100 mg. I hope this is very much clear. Let's go towards step 2. Step 2 is nothing but alpha is equal to 0.05, right? Okay, guys, this is 50 mg. Sorry for this. Okay. Everybody clear here? Now is the main thing. How do we calculate the degree of freedom? Everybody focus over here. See, in Python, we just use one equation, right? Here, it is completely different now. Here, we have to calculate the degree of freedom. Now, tell me, guys, degree of freedom is dependent on what all things? What all things degree of freedom is dependent on? 1, 2, 3. These categories are there. Rows are also there, right? So let's find out. Okay. And for this, first of all, we need to compute the degree of freedom between. Okay. And here we have something like alpha minus 1. Alpha is nothing but 3 because I have 3 categories. So this is nothing but 3 minus 1, which is nothing but 2. Okay. No, that R minus 1, C minus 1 will not work, guys. Understand? It will not work. It will be a little bit different. Then we compute degree of freedom within. In this, we basically use the formula n minus alpha. What is capital N? What is capital N? Can you tell me? What is capital N? Not just number of rows, guys. It is number of all the elements. 1, 2, 3, 4, 5, 6, 7. 7 multiplied by 3. It is the total population. Right? So it is nothing but 21 minus 3, which is nothing but 18. And degree of freedom total, obviously everybody knows this, n minus 1 will be there. So here I can write 21 minus 1 is equal to 20. Clear? Now guys will be saying, sir, why this formula? Suddenly you're changing the formula. No, these are all the possible things, guys. See, why this formula is basically used, that should not be our problem. Understand? Because there are 3 degrees of freedom over here with respect to all the categories, because categories are also important, right? Over here, categories are also important with respect to some numerical feature. That is the reason we are dependent on this. We are dependent on all these values. So degree of between, within, and total needs to be computed. Now the next step, this is the total values, guys. Just imagine that n is the total values that are present over here. Then the next step is basically my decision rule. In this decision rule, we need to basically follow degree between to degree of freedom within. So the total value will be 2, 18. How do we get this? Again, I'll open my browser. And search for F table. F table. What is F table? F distribution table. In F distribution table, see, you'll be having 2 degrees of freedom. This is 1, this is 1. Right? So what is my degree of freedom between value? 2, and degree of freedom within value is 18. So 2 comma 18 is what? Where do you see 2 comma 18? So this is my 2, right? And this is my 18, right? Guys, see, 2 comma 18. This value is there, 2.62. Do everybody agree with this? And always understand, for one-way F ANOVA test, you have to use this formula only. So can I say my decision rule is 2.62? 2.62? Yes or no? Just a second, guys. 2 comma 18. 2. Okay. Sorry. See, guys, one mistake. Here, FTEL for alpha is equal to 0.10 is there. What is our alpha value? Alpha value is 0.05. So we have to see this table. Okay. So here is our value, 3.5546. See, I'm going and check for F table for alpha is equal to 0.05. Right? So this will be my value. What is my value now? 3.5546. Everybody open the F table quickly. Is everybody able to see this or not? Guys, yes or not? We can have 2 more combination of degree of freedom. No, this will be this 2 to 18. Yeah, so 3.5546. So let me write it down over here. My decision rule is 3.5546. Now, what will happen if after performing this test, the test statistics, if it is greater than this value, what it will happen? You have to reject, right? Now, let's go and compute the step 5. Is everybody ready? Now, this will be a tedious process where you will pull your hair, okay, little bit, because calculations are like that only. Can't help, because everybody wants to know this, right? So I am creating this. So let's calculate the F test. So first of all, in this, I'm going to create of 3 fields like S sum of square, then we have degree of freedom, then we have mean square, then we have F value. Okay, let's create this table. I'll talk about it. And then I will create 3 rows. One is between, within, and total. Because the dependency is on all these 3, right? Now let's go and see how do we compute this sum of square. So first sum of square between we'll try to compute. Sum of square between is basically given by the formula summation of AI whole square minus T square divided by N. Don't worry, what is this thing? I'll talk about it, okay? Now let's go to the AI square. What is this AI square? Summation of AI. What is this summation of AI? Okay. So let's go over here and see this, guys. Summation of AI basically means I will take every row. Suppose for 0 mg, this will be my one feature. And for this, all this feature, I will add 9 plus 8 plus 7 plus 8 plus 8 plus 9 plus 8 whole square. I hope everybody understood. How did I take summation of AI whole square? Yes or no? Everybody. I hope you're understanding. I took this feature, I added up all this number and did square. right? Yes, everyone, do it, calculate it. Then after this, you need to add the next column numbers. Plus 7 plus 6 plus 6 plus 7 plus 8 plus 7 plus 6 whole square. Then you try to calculate whole square. Guys, it is not multiplication, it is plus. Okay, it is plus. So if I go and see these values now, the value calculation will be something like this. 57 square plus, because I have summation here also, right? 57 square plus 47 square plus 21 square divided by minus, sorry, this divided will not be there, minus, see, one formula I missed, it will be small n. What is small n, guys? What is small n? Cap 7, right? For that specific row, it is 7, right? So t square over here will be 125. Why 125? See, understand how this 125 is coming. We will add up this 57 plus 47 plus 21. This is what t specifies. This values is other, right? AI. This is basically getting added over here, and this total is 125. So here I'll have 125 squared divided by capital N as 21. I hope you're understanding how did we get t square? For every column, where is the total? It is just like this, summation of AI. Okay. So everybody, I hope you're getting it as 98.67. Yes or no? Yes. Everybody clear? So let's go and update this table. So SS between, how much we got? 98.67. Now the next thing is that let's compute for SS within. Now SS within, the formula will change little bit. Okay. It is nothing but summation of y square minus summation of AI whole square divided by small n. I think this will be the same thing. This and this both are same. I hope everybody agree with me. Yes. Now what is this y square? Let's see what is this y square. This y is nothing but, see guys, you have values, right? For 0 mg you have something like this, right? See, for 0 mg, or let me just copy and bring that entire diagram over here, then only it will be easy. See this, sir. See, what is this y square? How do we compute y square? See, we will take every value like this, 9, and we'll do it square. Then we'll take 8, we'll do it square. Then we'll take 7, we'll do it square. Then we'll do it square. Like this, we'll do everything as square, you know, and we'll do the summation. Then how much total values will be getting, guys? Tell me. Umang says ये तो बहुत लंबा calculation है. So you are interested in doing the calculation, right? So I'm doing the calculation for you only. So I had suggested to skip this only because it is not necessary, you know. We don't have to do any maths problem. So this will finally be 853. See this, guys. 853. Okay. Minus, just understand that this entire calculation, if I'm doing it, is nothing but 10.29. Okay, done. It's almost done. See this. Now here I'll just write it as 10.29. Okay. See, let this video get recorded, so that you can revise it whenever you want. Okay. Now total, how much, if I calculate this, how much it will be? 108.95. Okay. What is the degree of freedom between 2? Degree of within 18, right? And what is the total degree of freedom? 20. Okay. This mean squared is nothing but, we'll just try to divide 98 by 2. We will get something like 49.34. And then we'll divide 10.29 by 18. We'll get 0.57. And finally, our F value, the F value that we are actually going to compute, it will be the F value is very much simple to compute. The formula will be ms between divided by ms within. That basically means this value divided by this value. If I divide this two, I'll be getting 86.56. Now this is my F test value. Now you know what is your this value. It is 3.5446. What we should do? Tell me. We reject the null hypothesis. That's it. See, MS calculation is very simple, guys. What we do for MS, we just take this number, divide by this number. Divide. This is nothing but sum of square. Sum of square. Okay. And after performing the F value, this is the F test. We are dividing this value by this value. We are getting 86.56. Now total I got 86.56. But over here from the decision rule, how much should I get? Less than this, right? But it is greater than this. 86.57 is greater than this. Okay. Yes, SS calculation is done for the entire fields. Yes. Entire field, no? See, 57 square, 47 square, 21 square. SS within calculations. This is my SS within calculation, guys. Oh, summation of y square. Why are you getting confused with summation of y square? I told you, no? We have to do the squaring for every element. We have to do the squaring for every element. 9 square plus 8 square plus 7 square plus 8 square plus 8 square plus 9 square plus 8 square plus 7 square plus 6 square plus 6 square plus 7 square plus this all squaring. And finally, we'll be getting 853. Yeah, this will be 842.71. I hope so. And then you calculate it. So again, instead of doing all these things, what happened? Why you're saying capital N? No, capital N is nothing but all the values 1, 2, 3, 4, 5, 6. This is all at 21. No, understand, guys. Small n, when I say it's a sample, capital N is population. Over here, all the elements over here is given as capital N. This is my sample, which is 77. Okay. Clear? Too much, right? You are only interested for doing all the calculation. No, I showed you so. And here what we are doing, we are just applying one line to do all these things. It is giving you a p-value, and we have to reject or accept the null hypothesis. Yeah, calculation is time taming, but not by this, no. By this only one line of code. See, one-way ANOVA test. So I like statistics, If p is less than 0.05, that basically means, what is p is 0.05, less than 0.05? What does this mean? Yes, in interview, they'll not tell you to calculate. How to calculate y square? I told you, no, y square, Nikita, please listen to me. See, y square, you have to take every element and do the squaring plus summation. All the elements. Clear? Will they take practical of Python in interview? They may. How to calculate SS total? Do the sum, no? Do the sum of these two. Ambika, do the summation, no? Okay. So now you can raise your hand and you can talk to me. And before that, let me tell you one very important thing, guys. See, with respect to stats interview, focus on all the distribution, understand about transformation techniques. Okay. So basically for ANOVA, we have to remember our SHDF MF formulas. No, you don't need to remember any formulas. Okay. Yeah, Parija, what happened? SS total, I told you, no, you need to do the summation of both this. Okay, guys, raise your hand. I'll allow you to talk. Yeah, raise your hand. Yeah.
Hi, Krish. This is Rajni.
Yeah.
So about the, I have two questions. Number one, maybe you have explained it clearly, but I didn't get when to apply the t-test paired one and like pair test and one-way test. I didn't get that like
Which one?
when we have the data.
One way F test, you're saying?
Yes, when we apply this like one way and two way.
When we are comparing between 2 to 3 groups, more than 2 to 3 groups,
Yeah,
more than
that
2
I
groups.
understand. But what about one way and two way ANOVA?
See, in one way
ANOVA is multiple group, right?
yes, ANOVA means multiple group. That is right. You need to understand what is the basic difference between one way ANOVA and two way ANOVA. Okay.
Yes.
So one way ANOVA basically says that. I'll just tell you it. See, one way ANOVA basically says that it has at least, just a second. It has one factor and at least two levels. This basically means, suppose I consider gender as an example. It has male and female, right?
Yes.
So this is a factor, this is a labels. This is what one way ANOVA says, at least.
Oh.
And remember, these labels are independent.
Yes.
Okay. Now, if you say there is nothing like two way ANOVA as such, there is repeated measures of ANOVA. Repeated measures of ANOVA. Okay. Here, Same condition, but levels are dependent. Levels are dependent. Some example, if I want to say that probably a person is running on Monday, Tuesday, Wednesday. Suppose this person runs 20 kilometer on Monday, then Tuesday he may obviously decrease, right? In Wednesday also
Yeah.
he may obviously decrease,
Mhm.
something like this.
Okay. Okay. If there is dependency, then we'll go for
Yes.
repetitious.
Yes.
Okay. And my second question is, other than chi-square test, which is like for categorical variable we use, is there
Yes.
any other test also we use in the data science or not? I
Uh,
mean, means other non-parametric test, I mean.
I think most of them uses this chi-square only. There are
Okay.
some other, but not that important. You know.
Okay. Okay. So means they are not used in the data science.
Yeah.
Okay. And my final thing is when we were talking about the null hypothesis and alternate hypothesis,
Hmm.
my understanding is we in for null hypothesis we consider the events are independent.
Hmm.
So whenever we define our null hypothesis, we consider the independent event. So when we were considering the gender and the color selection by the kids, it was why it was taking not related because we consider every event as independent. Means there isn't any relation between selection and the gender.
Obviously, it should be like that only, but I still got confused with that problem statement. So just give me a couple of
Okay.
days. I will give
Okay.
you the because the confusion of selecting the alternate and null was only on that particular problem statement. Okay.
Yes.
So we'll
Yes.
discuss about that. Okay.
Yes. Thank you, Krish.
Yeah. Next
Good
question.
Hello.
evening, sir.
Hi.
Yeah.
Yes.
Yeah. Go ahead.
Sir, may I please?
Yeah. Yeah. Go ahead.
Sir, I was quite late in this course. I started few days back.
Mhm.
So, is there any way I can cope up with present classes and previous pre-recorded videos as well?
Yeah. Yeah. Obviously, you can look at the previous videos. No.
Sir,
Anyhow, everything is getting recorded. You can go with your own speed.
by the time I'm listening to and reading those previous videos,
Mhm.
so the present live classes are going on as well.
Yeah. It is
So,
only happening on Saturday and Sunday. No.
all right, sir. That's all right. Just one more thing. I'm in third year, so if I'm appearing for next year placements, how much data structure and algorithm is needed for job placements in
See,
related to data science
data
domain as
structures
well?
and algorithms will be required because the first round will be for with respect to that. Just give me a second, guys. Just give me a second.
Yes, sir, sure.
Yeah, data structures and algorithms will actually make you a good coder. For a fresher, obviously, first round they may ask related to Python programming language with simple problem statement. So I think it is good to have that knowledge. You still have time, no? Prepare with that. Already, data structures competitive programming course is also going on in iNeuron. So, but
Yeah,
I would
in
suggest
separate.
you start preparing for it. Start preparing for it. Don't uh, don't 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 actually ignore data structures and algorithm. It will be very beneficial till the end.
Yes, thank you.
Hello.
Yeah, hi. Hi.
Yeah, go ahead.
Yeah, hi Krish. My name is Srinivas. I would like to ask you like the stats to the ML mapping. Do you have like binomial distribution to the logistic regression
Hmm.
or something mapping can we have
Yeah,
if
yeah.
possible?
See,
Like
all,
each algorithm model to the
yeah.
stat model.
So, what mapping you want? Do you want something
Like
explanation?
generally for the binary logistic regression, the problem statement will be in the binomial distribution.
Not only binomial. The features may follow a normal distribution over there. The output that you may have will be in the form of zeros and ones. You know, so
Correct.
uh, and remember every feature will have a different kind of distribution. It can follow a log normal distribution. It can follow a Poisson distribution. You know how to do the transformation also. Everything as
Yes.
such. So those things will only get repeated over there.
Okay, there is no specific like one-to-one mapping or one-to-many mapping will not be there.
No, it may. That only I'm saying. Now in this particular logistic, it is a classification problem, binary
Correct.
classification. So there you may have multiple distribution, right? So understand, sometimes you try to combine everything. You may combine logarithmic data, you may combine Pareto distributed data, you may combine power law distributed data in a same data set itself.
Okay.
Okay, so
Okay.
that kind of problem statement, and probably when it will be discussed, when we are discussing about the problem statement, it will be discussed all those things.
Fine. Means for which model, which binary, like which stat model we need to use?
Over there, stat, don't worry about the stat model, because all these things are available in our sklearn library also. Okay, machine learning algorithms and all. Yes,
Okay,
guys,
fine.
whoever do not have any questions, they can leave. Thank you.
Hello.
Yeah.
Krish.
Hello.
Yeah.
Hello, sir. Am I audible, sir?
Yeah.
Sir, I have applied for PhD and I have given for research in field as a machine learning using Python. Sir, the question is like what type of question they can be asked and what means topic I have to more focus on.
Sorry, what again? Can you repeat the question?
Yeah, sure. I have applied for PhD
Hmm.
and in that I have given the research field on machine learning using Python.
Hmm.
So what type of questions can be asked from there and in what field or means on what topic I should focus more for interview purpose?
So whatever research you have actually done, they'll try to explore on that only, and on basis of that, they may ask you different questions. They may also
No,
include statistics and all.
okay, but they have given that like what topic on what field you want to do. So I've given one topic like machine learning. So in that, what type of questions they can ask like the whole topic or something like that?
They can ask you in machine learning. They'll say you that did you do any kind of end-to-end project? They may ask you related to the project. How did you do data collection? Probably
Okay,
how did you do this step? How did you do feature engineering?
okay, sir.
I think, guys, all the documents, whatever whiteboard that I have written is available now, right, in dashboard.
Yes, sir.
Today also I'll send it to the backend team. They'll upload it. Okay.
Thank you,
Okay,
sir.
guys, before I continue, let me just talk about some of the interview questions that may come with respect to statistics quickly. Please make sure that you discuss about all the distribution of data. Okay, binomial distribution, Pareto distribution, Poisson distribution, log normal distribution, standard normal distribution. Some of the good important theorems like central limit theorem. One very amazing question was that in an interview, a person told that, okay, just try to tell me what will be the average size of all the sharks in the world. Okay, so how do you solve this particular problem? Okay, over here you can use central limit theorem. You can also use central limit theorem. How do you use, right? You can use Z test. Okay, you can use Z test. I also shown you Z test, right? Because not Z test, sorry, T test you can use, because there you will not be okay. If you know the population standard deviation, then you can go with Z test. If you don't know that, then you can not go with Z test. You can go with T test. You can go with Chevin's inequality. You can go with central limit theorem. Okay, all these things you can actually combine a lot of things, and you can basically talk about it. This was very much important, and basic important terms like what is the differences between inferential descriptive statistics, how do you compare them, how do you try to explain them, okay, what exactly is hypothesis testing. Now I hope anybody do not have any problem with respect to hypothesis testing. At least you have understood hypothesis testing and how to explain it in front of the interviewer. Hypothesis testing and p-value, they'll always try to confuse you. Yes or no, guys? Confidence interval, okay, confidence interval and all. Hypothesis testing, why do we do this? What is the main steps of doing the hypothesis testing? Everything, right? Confidence interval, p-values, they'll mostly involved in this. Now, z-test, t-test, they'll not tell you to do Python programming. They'll say that when do you use z-test? When do you use t-test? When do you use chi-square test? When do you use ANOVA test? They'll not say that how do you use, what formula is there for that. No, this is a formula no one remembers. But when do you use what? That may be asked. Okay, like I may say that why do you use chi-square test? Today we understood, right? Now suppose if I say why do you use chi-square test, you can say that it is a non-parametric testing that is used for category features, for comparing category features, or to find out the relationship between the category features. Pretty much simple, right? Then how do you do it? Then you can add some more things, whatever you remember, right? This is very much important. Again, I'm telling you, please focus on the application part, how you are able to provide some kind of application. Okay. And probably in the future, there is also a topic that is going to come in machine learning called as confusion matrix. It is not like statistics is completed today. Tomorrow also you'll be getting something new. People may ask you about transformation techniques. Why do you do transformation? Right? We discussed about something like standard scalar, right? Why do we do standard scaling? Why do we do min max scaling? You know, all these kind of questions will get repeated again and again. Okay. So my suggestion will be that please revise in whatever I have actually taken. Okay. Whatever I have taken, because every reason, everything, because all the questions will revolve in this only. And if you have a good hold and grasp of with respect to statistics, trust me, you'll be able to do some amazing work. You'll be able to get the jobs very much easily. Okay. So overall, how do you like to rate this entire stats session, guys? What we did from past 4 to 5 days, past 5 to 6 sessions. How was it? Okay, how was it? Amazingly, did you understand? Will you be able to attend the interviews and all? You know, so this is what I really wanted to. But at the end of the day, the way that I have actually taught you is that you have an example. I've also show you how you can relate it with a real world problem statement. Okay, and all these things keep in mind. It will always be amazing. It will always be important, and you'll be able to learn more and more, gain more confidence in your interviews. Okay, so please try to go in this specific way. Yeah, go ahead with the next question.
Hi, Krish. Ankit this side.
Yeah, Ankit.
So Krish, my first question is that's the same. I'm also a new joiner. Today is my first class, and the feedback is yes, I liked it very well because few examples that you have shared, real examples, so that really helped to understand the topic very well. And point is, I know I need to cover like 2.5 months course. So in terms of assignment, so is there any timeline that I have to?
Okay, with respect to assignment, there is no that much timeline. Okay, try to give it whenever you can, but make sure that you at least give every day 1 to 1.5 hours every day. Then only you'll be able to cover things.
Sure, Krish. And second question is, Krish, I have a 6+ experience in data and analytics. I worked on SAS, Teradata, and just started working on with Python. So point is, now I'm planning to switch on to data science. So that's why I have opted this. And I keep watching your videos on YouTube to understand the more topics. Like, so will I face any issues as related to my experience? And now, like, my experience is getting more and more. And now I will.
No problem. You can do it. It's not a problem at all. Don't worry about that. Don't think about that. A person who is more than 20+ years of experience has made a switch. Okay, so you can also do it.
Sure, Chris. Thanks.
Yeah.
Thank you.
Yeah.
Krish, we have discussed about chi-square test today to relate the two categorical variables. For that, we used alpha equal to 0.05. Normally, alpha will be given by the domain people.
Expert.
Yeah. But as per this correlation between two category variable is concerned, this we have to take 0.05 only, or this also will be given by the domain expert.
No, see, 0.05 basically means 95% confidence interval. Just think in that specific way.
Okay.
Okay. So if anytime, right? If you just go and do any medication test also, like COVID test, there also you'll say take at least 95 to 99% confidence interval, no? Because the doctors will definitely say that, oh, this much is fine, this much infection if people are having, they'll get well, you know, something like that.
So we can normally use 0.05 even for correlating two categorical variables. And one more question, Krish. Suppose we have as per the ML model, we will get the for classification purpose, we will get the two results. One is the accuracy and one more is the ROC score. So when we have to consider these accuracy score for the judgment of the model, and when you have to consider ROC,
there you have to focus on false positive and false negative. Whether you want to improve false positive, whether you want to improve false negative, whether you want to reduce false positive, false negative, whether you want to improve true positive, true negative. You know, that depends on the problem statement again.
So it depends on the business problem what we are having. So we are based on that, we have to decide whether we have to go for the accuracy or ROC.
Yes.
Okay. Okay. Thank you, Krish.
So am I audible?
Yeah.
Could I go ahead? Hello.
Hello, Krish. Yeah, go ahead.
Yeah, sir. So I have a question with respect to t-test. Sir, we use z-test when there is normality. So do we use t-test when we do not have a normality in our question? When there is no normality, do we use t-test? This is my question.
When do you do not have normality? What do you mean by normality?
Sir, as in we have a normal, our data set is following normality. So if we are doing some test on that time we use z-test, and or we can use t-test also there.
There also you can use t-test. That is not a condition as such.
So the only condition between z and t-test is that the population
Standard deviation
not given in size
and your sample size. Yeah.
But sir, I have seen in few examples wherein in that z-test formula x minus mu divided by sigma, right? So we will be using z-test when population standard.
That is for population. Okay, if you are dividing by sigma, okay, that is a population. But in case of sample, you will divide by s divided by root n.
Okay, sir. My question is that we use t-test when standard deviation of population is not known and n is less than 30, right? But I have seen that we have used this z-test when population standard deviation was not given, and still we have used z-test. Only the difference was that n was greater than 30. So do we have a
where you have seen?
In statistics module only, sir. iNeuron one document is there. I was solving one numerical. So there they have used x minus mu divided by s by root n.
I think that's just for an example case. I think that is done.
Yeah. So my question is, can we use like that also?
Yeah. Just for verifying purpose. See, whenever you have a data set, right, and whenever you are taking a z-test and t-test and all together, automatically it will be taken care of by the library itself. You don't have to worry about it. Okay.
Okay. Yeah. Thank you.
Hi, Krish.
Yes.
Yeah. Can I go forward?
Yeah. Go ahead.
Yeah. Thanks, Krish. Krish, I just have a very small doubt in regards to the calculation that we have done for the chi-square test, like today's first problem in regards to the 2000 census, like in the year 2000 census. So one value was taken in regards to the percentage and the other one was given in terms of number, right? Like the age between.
First one was the population percentage. Like there was a population and this much percentage is there. They have just given that specific value. Then what they did is that they picked up a sample of 500 people. And they said that from that 500 people, this many number was below 18. This many number was between 18 to 35. Yeah.
Yeah, the second one was given in numbers and the first one was given in percentage. And depending upon the sample size, like the 500, depending upon taking that number, we have changed the percentage to the numbers and then did the calculation. It's just like, I mean, it may sound foolish, but can we just do it the other way around, like converting both of them to the percentages and then going on with the formula?
But understand that observed value may not be same, no? Observed value may not follow the population. That is what we are trying to test, right?
Yeah.
So we should not convert that back into a percentage.
Okay, like the numbers that we have got to the percentage. So I just thought maybe I actually tried doing it in that way, like converting this to the percentage and then getting the value of the chi-square. But it was also like same. It got the null hypothesis. Yeah, I mean null hypothesis was rejected and the alternate hypothesis was like needs to be taken. So I just wanted to confirm that with you.
I did not try it out. Let me have a look then. If it is coming, same values are coming, then I think it will work.
Okay, and there's one more thing, Krish. Here we have the n value, like degree of freedom, right? Where we'll be taking the n value, and here there's a limit of 100 in the chi-square test table, right? For the degree of freedom n value. So will there be any case like that we get an n value more than 100? And this chi-square test still needs to be taken.
It can be possible. It can be. See, whenever you say about problem statement, it can be there, right?
Yeah. So in that case, we're not going to consider the chi-square test, Krish?
Again, can you repeat the question?
No. I was just saying, like in the chi-square test table that we have seen here, like in the Google, the n value seems to be only until 100.
No, it can be above 100. That is not a problem.
Oh, okay. Then maybe I might have messed up. And last question, Chris, I just wanted to understand if there could be any reference book that you could suggest, for statistics.
I think ISLR book is attached in your this, right?
Oh,
Stats in ISLR. I'll just tell the team to attach it in your dashboard. Okay.
okay, great. Thanks. Thanks much, Krish.
Hi, Chris. So,
Yeah.
can I
Yeah.
speak?
Go ahead.
Sir, what is critical region?
Critical region is same like your decision rule, no? That value that we are getting.
And second question is, why in most cases null hypotheses are rejected?
Not in most of the cases. We got like that. If it was lesser than that, if you take the chi-square test value, right?
Okay.
Try to take the same proportion. That will not get rejected.
I will.
Hi, Krish.
Hi, Krish.
Krish. Yeah, good evening. One question here. For example, in machine learning, you are creating different samples for training the models. For example, you have created the sample. So to test whether the sample I have selected, the 20%, whatever it may be, it is perfect. It will be perfect for my model or not. So is there any test we can choose for that?
Yeah, we do validation by using validation data set, no?
Yeah. Okay. So any test like stat test like we have learned that can be.
Stat test is not required for that. Performance metrics will be there for machine learning models. Don't worry.
Okay.
Yeah.
Hey, Chris, this is Soumya here.
Soumya, go ahead.
Yeah, for calculating the degree of freedom for different use cases, we are using different kind of formulas. So how to know which formula to use in which use case? So can you just tell me
Very
a shortcut
simple,
for-
no? For ANOVA test, I've shown you. For chi-square, there will be categories. You know, if there are two categories, then you have to use a different degree of freedom. For t-test, obviously you have to use a degree of freedom. Why? Because population standard deviation is not given. Whether for z-test any degree of freedom needs to be calculated, tell me.
Test.
No, because
No.
their population standard deviation is given. For t-test, it is very simple, n-1. For degree of freedom, like for chi-square, suppose there are two degree of freedom will be very much simple, right? Based on number of categories. Each category is -1. It will be multiplied by that. Like in our chi-square, we had gender and we had color, right?
Yes.
In gender, inside that, how many values we had? 2. In color, we had 3, right?
Yes.
So 2 minus 1 multiplied by 3 minus 1.
That is for chi-square.
Yeah, chi-square. For ANOVA, I told you between
Within and total.
Yeah, and also make sure that you check the table of them. Then only there you'll be able to find out, right? In chi-square, we could find out 2 degree of freedom was there, right? Sorry, in ANOVA test, we are able to find out 2 degree of freedom was there, no? In ANOVA
Yes.
table.
Yes.
Between till within, like that.
Okay.
So
Yeah,
as if you revise, automatically you'll get to know. Okay.
Okay. Yeah. Thank you.
Okay, guys. So this was it from my side. I know it is not possible to take all the questions, guys. Just understand, but don't worry. Everything will be in place. You have to learn. You have to revise. You have to keep on learning and revising. Okay. So all you have to do is that revise those things and keep on working on those things. Okay. And see, again, I'm telling you, focus is to get the job. You don't want to become a statistician. Okay. Try to learn only those things that are necessary. Statistics is also a huge subject. And whatever I've actually taught you till here, that all things will be necessary for machine learning also as we go ahead. Okay. So this was it. Do we need to learn big data for data science? If you are an experienced person, some amount of big data knowledge is required. So in this course, you will have big data also. Is Gaussian distribution and normal distribution different? Both are same, guys. Okay. Can you please point to some Python scripts or stat pricing as reference of what you taught so far? I've already given. Guys, all the materials has been given to you, no? Everyone, just tell me. Guys, all the materials has been given to you, no? Whatever I've shown you till now, every materials has been added to your dashboard, and I also give you the whiteboard also. Okay. Sir, F test where we use? So F test in ANOVA test, no? We did, right, Khushbu? Yeah, from tomorrow, Sudhanshu sir will be coming. He'll continue your Python remaining section from Pandas. And we are pretty much, very much good. I think in a couple of sessions, we'll be able to couple 2 to 3 sessions we'll be able to start machine learning. Sudhanshu has to take for you pandas, numpy, and some amount of seaborn, matplotlib and all. So I think within 2 to 3 weeks machine learning will start. Happy? And from 15th I think most of your internship will also start, right? So thank you. And yes, other things, I hope you liked this 6 days of mine. I hope you liked it, guys. And I'll be coming. I'll again come in machine learning. Don't worry, where I'll teach you the maths like how I taught you everything. Okay. The level of teaching with respect to statistics, you're satisfied with that, right? Right? Okay, perfect. Thank you. Thank you. And all the materials, everything, I'll be providing it to the backend team. They'll try to upload it in your dashboard. Okay. And yes, guys, continuously revise. You'll get better in statistics. Okay. So thank you, everyone. Bye-bye. Have a great day. And yes, keep on rocking, keep on learning. And don't forget to provide your feedbacks in the iNeuron Google review, if possible. If you like my teaching, that would be very, very helpful. Thank you. Bye-bye, guys. Have a great day. Thank you, everyone. Bye-bye. Thank you.